Okay. Are you able to see the solution?
Yes, sir.
Yeah.
Yes, sir.
Okay. Yeah. So you can verify your solution against this program. Okay. It's not necessary that you should have written exactly the same code. Okay. There could be multiple ways. If you have any queries, go ahead, ask me. Okay. So in the check prime function, what am I doing is I'm checking. Suppose there is a number num which I have to test whether it is prime or not. Then in the range 2 to n minus 1 or 2 to num minus 1, I should not have any number I that divides the given number, leaving a remainder 0. If there exists such a number I that divides leaving a remainder 0, then it is not a prime number. Okay, so I am using false here, and see, I have used return false. Okay, so this return statement also acts like a break only. Okay, it comes out of the for loop and even the function itself. Okay, so I have there is no requirement for the break statement. Okay, so if there is any such I which divides num leaving a remainder 0, check prime will return false. If the function executes and there is no I that satisfies this condition, the body finishes the execution of the for loop and then comes to the next part. Okay, so if the for loop has finished execution completely, okay, so starting from 2 to num minus 1, it has checked every value and none of them divide the number leaving a remainder 0, then the given number is prime. So in which case, outside the for loop, see, I have written a statement return true. Okay, saying that the prime number is the given number is a prime number. Okay, so n1 and n2 we have asked the user to enter the values, and again input validation. What I have done is perform the code only when n1 is less than n2. Okay, when I define a range, the first number should be smaller than the second number. Okay, so if that is the case, if n1 is less than n2, if it is true, then the problem is to find out all the numbers in the range n1 and n2, including n2, and display only those numbers that are prime numbers. So I have written a loop, okay, for j in range n1 to n2 plus 1, because I want to include n2 as well. I have written n2 plus 1. Okay, so if this j that runs in the range n1 up to n2, I am passing j as a parameter to the check prime function. Okay, this is the function call. Check prime function returns true or false. So I have written if check prime, if true, display print j. Okay, yeah, so display the value of j. Otherwise, do nothing. Okay, so for numbers that are not prime, they don't get displayed. Okay, so in the sample output you see here, I have given the values as 4 and 25. In between 4 and 25, it takes each values. Okay, it does check prime of 4. 4 is not a prime number, it returns false. So this print j will not be executed. Okay, if false, will be treated as negative and it won't be displayed. Next, j will take up the value 5. Okay, check prime 5 will be true, so it displays 5, and so on. Okay, so it displays only the prime numbers. Okay, next, we will try to solve a slightly larger problem. Okay,
Sir, I have a doubt.
take down. Yeah, go ahead.
Sir, but when you input one, it even shows one as a prime number
Where?
for n1 and n2. If I put one as
Okay,
n1,
okay. Yeah. One should also be a special condition. right? Okay. So we need to do some more input validation. Okay. So n1 should be at least greater than 2 or something like that. Okay. Because 1 is neither prime nor a composite number. It's a special case. Maybe you can write additional code for that. Okay. Or enter two values separated by comma, you can specify that n1 should be greater than 1, something like that. Fine.
Yes, sir.
Hello. Yeah. Oh. Hmm. Okay. So take down another question. Write a program. Write a program to calculate the area under a curve. Area under a curve for the equation for the equation 3x cube 3x cube plus 2x square plus
Sir,
5.
can you repeat the question after 3x cube?
Yeah. Just a minute. I will share that only. I am typing it as well. Let me share.
Okay, sir.
Where did it go? Yeah. 3x cube plus 2x square plus 5. Or instead of being specific, okay. Just rewrite the question. For a equation of degree 3. For a equation of degree 3, whose coefficients whose coefficients are read as input from the user. Within 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 a range of a and b. Within a range of a and b, or limit a and b. Okay. Using the trapezoidal approximation. Using trapezoidal approximation method. Okay, any doubts in the question? Should I repeat the question again?
No, sir.
Yeah. Okay. Okay. So consider we have a polynomial or a equation of degree 3. Okay, so a degree 3 equation will have how many coefficients?
3.
Think carefully. What we mean by a degree 3
Sorry.
polynomial? Huh?
The highest power of the variable is 3.
3. Okay. So it can have a max of 4. Okay. X cube, x square, x power 1 and x power 0. So there could be 4 coefficients. I have given an example. Can you see an example here? Highlighted one. Hello?
Yes, sir.
Is it? Yeah, yeah. Okay. So here the coefficients are 3, 2, 5 and 7. Okay. So we will ask the user to provide this values, okay, and accordingly decide upon the polynomial. Now, apart from these coefficients, we also get two more values, let's say a and b. So I have to find out the area under the curve in between these two limits a and b. Okay. So have you heard of this trapezoidal approximation? Okay, let me tell you. Maybe this image should, maybe you may remember. Can you remember this? Hello. Uh, okay. If you don't know, let's assume that this line, okay, line in pink. Can you see this diagram, Disha, Tanmay? Hello, Tanmay. Can you hear me?
Yes, sir.
Okay, okay, okay. I think Disha just dropped, I guess.
Yes, sir.
Let me just wait for her to join. Yeah. Okay. Disha, am I audible now? Hello. Hello, Disha. Disha, can you speak back? Can you hear me?
Yes, sir. I can hear you.
Yeah. Okay. Okay. Fine. Yeah. So we were talking about the trapezoidal approximation. Okay. So what we will do in this is, suppose say you have a polynomial. Okay. Consider this so some polynomial y is equal to f of x. For example, it could be our polynomial of degree 3. Okay. So I want to find out the area under this curve within the limits, let's say a and b. Okay. So what we can do is, instead of trying to find this area as a whole, what we do is we apply the method called as trapezoidal approximation. Okay. I take a small length, let's say delta x. Okay. This delta x is the distance between, let's say, a to x1. Are you able to see this diagram? Can someone confirm?
Yes. Yes, sir.
You're able to see the diagram. Okay. So I choose a small length delta x. Okay. So in this example, the distance between a to x1 or x1 to x2 or x2 to x3, let's call it delta x. Okay. And then we start creating trapezoids whose width is delta x. Okay, successive trapezoids. Okay. So the smaller the value you choose, the better approximation you start getting. Okay. So at every delta x intervals, I call them x1, x2, x3, x4, and so on. Okay. So now you could see that it forms a trapezoid here. The first one will form a trapezoid, second one will form a trapezoid, and so on. Okay. And we calculate the area of each trapezoid, and then after finding out, we add all the areas of this trapezoid form, and that will give us an approximate but close to the exact answer. Okay. So this is called as the trapezoidal approximation. So for finding the area of a trapezoid, we should be knowing the base and height 1 and height 2 of the trapezoid. Trapezoid has two heights. So it would be the average of the two heights multiplied by the base. That is the area of the trapezoid. Okay. So to calculate height 1 and height 2, we just need to apply the values of x here into the polynomial, and then we will be able to find out the area of the trapezoid. Okay. So what we will do is, now that you have understood the method, okay, so I will just outline you the procedure. Okay, first we will, in the main function, we will read the input values. Okay, so the input values will be the four coefficients and the two limits a and b. Okay, so this after reading these values should be passed on to a function called as calculate area. Okay, calculate area under the curve should in turn call upon a function called as calculate area of a trapezoid. Okay, so every time you calculate, you are going to call the calculate trapezoid function. The calculate trapezoid function should contain code for calculating the area of a trapezoid. After calculating the trapezoid, the calculate area function should sum it up, add it up to the previous areas of the trapezoids. Okay, that's the idea. So try this on your own. Try to write code on your own for this. Okay. If possible, it's good. Otherwise, anyway, I will solve this in the next class. Okay. So when do you want my next class? Tomorrow? Do you have any issues with having the class tomorrow?
No, sir.
No, sir.
I don't see any energy.
You can take class tomorrow, sir.
Okay, fine then. So same time 6:30 to 8:30,
Yes, sir.
or 6 is fine. Today I had a session that went late, so that's why I could not start at the right
Sir,
time.
we can do 6:30 because I usually reach home by 5:50. So,
Okay, fine then. No, so let's start by 6:30 itself as usual. Let's do it by 6:30 to 8:30. Fine then. Okay. So we'll have the class tomorrow at 6:30 to 8:30. Um, we will solve this exercise tomorrow then. Okay. 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 Then. So we'll stop it here. Let's see in the next class.
thank you, sir.
Okay.
Thank
Yeah.
you, sir.
Bye then.